Hello students. In this video we are going to discuss about the fission of a covalent bond. Fission means the breakdown of a covalent bond. The fission of a covalent bond, that is the cleavage of the covalent bond, either takes place by heterolytic cleavage or homolytic cleavage, which is also called as heterolytic fission or homolytic fission. In heterolytic cleavage, the bonds breaks in such a fashion that the shared pair of electron remains with one of the fragments. Let us take one case here. In this example, we can see that there is a bonding between the carbon of methyl group and Br. That bond, it is having these two electrons. Now what happens when this bond get cleaved? So the electron of this bond is shifted towards one of the fragment, that it is shifted towards Br. That is what it is called in the definition. The bond breaks in such a fashion that the shared pair of electron, that is these two electrons shifted to one of the fragment, and because of here the electrons are shifted to Br, therefore it develops a negative charge here, and the other fragment develops a positive charge. If we take the case of the example, that is if AB is a molecule in which the bond between the AB, if it is cleaved in such a way that let the shared pair will be taken by B. So what will be the product formed? The B develop negative charge because the shared pair is transferred towards B. That means B develop a negative charge because of that electron which is shifted to B, but A develops a positive charge. So the same thing is happening what it is explained in this example. So here it results in the formation of a carbocation. Let us see what is the definition for carbocation. A species having a carbon atom possessing the sextet of electrons and a positive charge is called as a carbocation, which is earlier named as a carbonium ion. So carbocation, which is formed here, this is the carbocation. What is the carbocation? It is a species in which the carbon having a positive charge, and when you check here the surrounding to this, it have how many electron here? Because this is, I have expanded the formula of CH3 plus, that is a carbocation. Now surrounding to this carbon, you can check how many number of electrons are there, because 3 bonds are there surrounding to this, and each bond means 2 electron. So total 6 electrons are there. So here it have a deficiency of electron to this carbon, because we know that carbon is tetravalent, but here there is deficiency of electron, it develop a positive charge here. So that is why it is called as the species having the carbon atom possessing sextet of electrons, that is 6 electrons, and it have a positive charge on it. So such is called as carbocation. Now why the word cation is used? Because positive charge is there on it, and carbocation, that means carbon bearing positive charge here. If we take another example, that is a CH3Z, where Z is any group. In this also heterolytic fission is taking place. The cleavage is taking place in such a way that this electron pair is shifted towards the methyl group, in which the carbon is developing a negative charge and the other fragment, that is developing a positive charge. So this result in the formation of carbanion. Now here let us define what is carbanion. It is a carbon species carrying a negative charge on the carbon atom is called as carbanion. Here in both the cases heterolytic fission or the cleavage is taking place, and this fission is taking place in such a way that the shared pair of electron shifted towards one of the fragment. Like here it is shifted towards Br, that's why develop a negative charge on this fragment, and in this case this electron pair is shifted towards carbon of the methyl group. That's why it develop a negative charge. So it results in the formation of carbocation, and this one is resulting in carbanion. Now let us discuss more in detail about these. Carbocation is defined as a species having a carbon atom possessing sextet of electrons and a positive charge, that is called as carbocation, earlier which was named as carbonium ion. Let us take the example of a carbocation, that is methyl cation. The formula is CH3 plus. This is called as methyl cation because it having a methyl group with a positive charge, therefore it is called as methyl cation. Methyl cation, which was also known as that is methyl carbonium ion. It can also be called as methyl carbonium ion. Let us discuss the structure for methyl carbocation, that is this one. Methyl cation, the formula is CH3 plus. Here the carbon is sp2 hybridized. So here we can see in the geometry there are 3 sp2 hybrid orbital which is shown here. These are the 3 sp2 hybrid orbital which is overlapping with the 1s orbital of hydrogen. So each is overlapping with the 1s orbital. This is the 1s orbital of hydrogen, that is it is overlapping with the sp2 hybrid orbitals of carbon. So it results in the formation of a sigma bond. That is a sigma bond is formed here, that is between the sp2 hybrid carbon with the 1s orbital of hydrogen. Here overlapping is taking place. It results in the formation of sigma bond. Here also sigma bond, here also sigma bond. So here between the carbon and hydrogen sigma bonds are formed. That is due to the overlapping of sp2 hybrid orbital of carbon with the 1s orbital of hydrogen. It results in the formation of a sigma bond. But when we look the side view of the structure which is shown here, in this the sigma bond is shown here, that is a bonding is shown between the carbon and the hydrogen which is shown here. But here the each bond which is represented here like a line, but the remaining carbon orbital, that is remain as perpendicular to the molecular plane, that is shown here, which does not contain any electron, that is a vacant p orbital. This is the remaining orbital of carbon which remains perpendicular to the molecular plane and it have no electron. So this is what the side view of this structure, that is the structure of methyl cation. From the structure we can conclude that carbocations have trigonal planar shape. It have trigonal planar shape with a positive charged carbon being sp2 hybridized. These carbocations are further classified as primary, secondary and tertiary carbocation depending upon the number of alkyl group attached to positively charged carbon. Here look at the case of methyl carbocation which is shown here, methyl carbocation. Here this carbon have a positive charge, but when you look at here, this is attached to 3 hydrogen. That means there is no carbon on this, which is the positively charged carbon is attached. But when you look at the case of primary, in the case of primary carbocation, the positively charged carbon is attached to the one alkyl group. Alkyl group will represented by R. That means it is having a bond between the positively charged carbon with the alkyl group of carbon. So depending upon the number of carbon atoms are directly attached to the positively charged carbon, it is classified as primary. Primary, which can also be represented as 1 degree. It is also called as 1 degree carbocation because here positively charged carbon is attached with 2 hydrogen and there is a single alkyl group. So in simple way, just count the number of alkyl group which is attached to this positively charged carbon. Here there is one alkyl group, therefore it is called as primary. Here there are two alkyl group, therefore it is called as secondary, which can also be represented as 2 degree because the positively charged carbon is attached to 2 alkyl group, or we can say it is attached to 2 carbon, directly attached with 2 carbon and 1 hydrogen. So we have to just count the number of carbon. So this positively charged carbon is attached to 2 carbon directly, that is the carbon of alkyl group. But when it have a 3 alkyl group, when the positively charged carbon is directly attached to 3 alkyl group, then it is called as a tertiary, which can also be written as 3 degree. So here we have learnt the classification of carbocation, that is 1 degree, 2 degree and 3 degree, which is also called as primary, secondary and tertiary carbocation respectively. So how we can define this classification? That is carbocations are classified as primary, secondary or tertiary depending on whether 1, 2 or 3 carbons are directly attached to the positively charged carbon. So it is very important point about the degrees because this concept will be used most of the places. So how you remember how it is 1 degree? Just look at the positively charged carbon and number of alkyl group, because alkyl group have the carbon. So there is a direct linkage between the positively charged carbon with the alkyl group carbon. So on the basis of number of alkyl group, it is represented as this. It can be written also in this short way, in this way, that is it can be written as R3C plus, that is tertiary. If all the alkyl group are same, we can write this one as like this. Secondary can be written as RCH plus. This can be written as RCH2 plus and this one is CH3 plus. So in short we can write like this also. When we look at the stability, that is the relative stability of carbocation, that is tertiary is more stable than secondary, then primary and the methyl. So the relative stability of carbocations, which is quite important during the mechanism for any reaction, which we'll be going to learn in the further classes. So that can be depend on the basis of relative stability of carbocations. Carbocations are the intermediates formed during the reaction. So depending upon their stability, the product will be decided. So it is very necessary to learn, that is the stability of carbocation. 3 degree is more stable than 2 degree, 2 degree is more stable than 1 degree, and which is more stable than the methyl carbocation, that is CH3 plus. Now let us discuss about carbanion. Carbon species carrying a negative charge on the carbon atom is called as carbanion. When we look at the geometry of carbanion, the negatively charged carbon atom in this, that is sp3 hybridized. It is sp3 hybridized. Therefore, the geometry for this one is tetrahedral. Note down, its geometry is tetrahedral. You are already familiar with the hybridization sp3. So the carbon is tetrahedral, having a tetrahedral structure. So the negatively charged carbon atom in the carbanion is sp3 hybridized and its geometry is tetrahedral. So here There are 4 hybrid orbitals. From this, 3 hybrid orbitals overlap with the 1s orbital of hydrogen. So it results in the formation of sigma bond. So here 3 sigma bonds are formed. But there is one hybrid orbital in which the electron will be remaining at this as lone pair. So this is the structure is similar to the structure of ammonia we have learnt. In the ammonia also we have learnt the structure in which N is sp3 hybridized and 3 hydrogens are there, and there is one lone pair with nitrogen. Similarly here also the carbon, the negatively charged carbon is sp3 hybridized, and the 3 sp3 hybrid orbital is overlapping with the 3 hydrogen with 1s orbital. It overlaps, so form 3 sigma bond, and one of the hybrid orbital it have the lone pair. So its geometry is tetrahedral, but the shape is pyramidal. Its shape is pyramidal, as I told you, just like the shape of ammonia, because of the presence of one lone pair. Carbanion is further classified as that is primary, secondary and tertiary depending upon the number of alkyl group attached to the negatively charged carbon. If there are 3 alkyl group which is directly attached to the negatively charged carbon, then it is called as tertiary, which can also be represented as 3 degree. And if there are 2 alkyl group which is shown here, then it is called as secondary, or which can also called as 2 degree. And if there is one alkyl group, then it is called as primary. And if there is no alkyl group, all these are hydrogen. That means negatively charged carbon is attached to 3 hydrogen, then it is called as methyl carbanion. So this is what the relative stability when we compare for these, it is in this way. That is, methyl carbanion is more stable than primary, then secondary and tertiary. So the relative stability is decreases in this direction. That means the least stable one is the tertiary, but is the most stable one is the methyl carbanion. So this is what about carbanion. Now let us discuss the next type of fission, that is homolytic fission. In homolytic cleavage, one of the electrons of the shared pair in a covalent bond goes with each of the bonded atoms. Thus, in the homolytic cleavage, the movement of a single electron takes place instead of an electron pair, as we have learnt in the case of heterolytic fission. Both the shared pair electrons are shifted. If I am taking the case of a general case AB. So if the cleavage is taking place in the way that is in the heterolytic cleavage, if it is taking place, both these electrons will shifted. But in the case of homolytic fission, one electron is shifted to one fragment and the other electron is shifted to the other fragment. There is an equal shifting of electron, that is the shared pair of electron in that covalent bond goes with each of the fragments. That is it is only one electron is shifted here, that is one electron to one fragment and the other electron to the other fragment. So what we can say, there is a homo means equal sharing of electron. That means there is a each electron goes to the each fragment. That's why it is called as homolytic. So this fission results in the formation of free radicals, that we can better explain through this example. Here Rx, here the bond cleavage is taking place. So the bond cleavage is taking place in a homolytic fission. That means we can see that the electron pairs are equally distributed. That means one electron of the shared pair goes to X and the other will goes to the R. So that's why it develops free radical. This is called as free radical. Thus, in the homolytic cleavage, the movement of single electron is taking place instead of electron pair. In the case of heterolytic, both the electrons are shifted to one fragment, but here only one electron is shifted to one fragment, the other electron will be shifted to the other fragment. That's why it is called as homo. That is, equal shifting of electron is taking place to both the fragments. This is resulting in the formation of a free radical. How you represent the free radical? That is, alkyl free radical will represent with R with a dot. So this dot represents the free radical. Let us discuss more about free radical. Free radical, that is a neutral species which can be an atom or the group which contains an unpaired electron. These species are called as free radicals. Now what is the structure for this one? It's a structure, better we can make the structure for methyl free radical CH3 dot. Here the dot is representing the free radical. So in this free radical, the geometry for the carbon that have bearing that dot, that is actually, it is sp2 hybridized. So just make a sp2 hybridized, that means the geometry is trigonal planar. So the sp2 hybridized carbon, it is overlapping with the 1s orbital of hydrogen in this way. So it forms a sigma bond. That is, here the sigma bond is formed between this carbon, that is sp2 hybridized carbon, with the hydrogen. So here one unhybridized orbital is there, and that unhybridized orbital have an unpaired electron, that is one dot I am making on it. That is an unhybridized orbital containing an odd electron. This is what called as odd electron. So the unhybridized orbital, it contains one odd electron. That is what we are representing as a dot here in the case of free radicals. So the free radical are actually the neutral species. It neither have positive charge nor have negative. This is a neutral species which can be an atom or a group. And it have an unpaired electron, that is an odd electron is present. So that's why it is called as free radicals. And the geometry is that is trigonal planar geometry, in which the carbon is sp2 hybridized. Here the carbon is sp2 hybridized. So here the 3 sp2 hybridized orbital is overlapping with 3 hydrogen, that is with 1s orbital of hydrogen, and the unhybridized bearing an odd electron. So this is what the geometry of free radical. When we look at the stability of tertiary, secondary and primary free radical. So it is clear from this that is tertiary is more stable than secondary, then primary, and last, that is the minimum stability is for the methyl free radical. This as I told already, what is the tertiary, you can make in the same way. Let I make the tertiary free radical in this way. That is the carbon that having a dot. Here there is one alkyl group, here there is one alkyl group, and here there is one. So 3 alkyl groups are there. Then it is called as tertiary, which can also be represented as 3 dot. And don't forget to keep the dot, that is showing the free radical, that is the odd electron. So better just bold that dot. Now how will be making the structure for secondary? In the case of secondary, what will be there? So better I will make separately secondary. In the secondary, this carbon having 2 alkyl group. That is why 2 degree. 2 degree means 2 alkyl group and 1 will be the hydrogen. So here also you have to write that dot. So this is the structure for 2 degree. So what will be the 1 degree? In 1 degree only 1 alkyl group will be there. So that is here the what is given in this image. In the place of R, it is written a group methyl. So if this is methyl, this is methyl. So CH3 thrice, that is what it is written here. That is CH3 thrice C dot. If two alkyl group are there, CH3 twice, and if it is only one, CH3, and this is the methyl free radical. So the least stable one is methyl free radical, and the most stable is the tertiary free radical. Let us differentiate between heterolytic and homolytic fission, which is an important question. In exams, you will be getting a question, differentiate between homolytic and heterolytic fission. The first point you can write the definition for both them. The second point you can write, here there is a formation of carbocation or carboanion, but in the case of homolytic fission, there is a formation of free radicals. The second point you can write about the formation of the carbocation and carboanion and free radical. The third point you can write here, that is the organic reaction which proceeds by heterolytic fission are called as ionic or heteropolar or simply polar reactions. So such reaction which takes place by the formation of the carbocation or the carboanion, that is through heterolytic fission. Such reactions are called as polar reactions or ionic reactions. But the organic reaction which proceed by homolytic fission are called as free radical or homopolar or non-polar reactions. These are called as non-polar reaction. So we'll be discussing more about this one when we do the mechanism for the particular reaction. So better write these points as in the differentiate between these two. How we differentiate between carbocation, carbanion and free radicals? As we have already discussed, its a definition, structure and the stability. So we can write these points in this way, that is carbocation are positively charged, carbanion is negatively charged, having negatively charged carbon, but the free radicals are neutral, having an odd electron with carbon. So in the carbocation, carbon have positive charge, here the carbon have negative, in this the carbon have odd electron. When we check the hybridization of the positively charged carbon in carbocation, that is sp2, here the carbon having negative charge, the hybridization for that carbon is sp3, and here that carbon is having hybridization sp2. That's why the geometry here for carbocation is trigonal planar, here it is tetrahedral geometry, and here also trigonal planar. And it is formed during the heterolytic fission, and this carbocation is formed during heterolytic fission, but the free radicals are formed during the homolytic fission. When we look at the relative stability of 1 degree, 2 degree and 3 degree, 3 degree is more stable than 2 degree than 1 degree for the case of carbocation. Similarly, for the free radicals also, 3 degree is more stable than 2 degree than 1 degree. But in the case of carbanion, 1 degree is more stable than 2 degree than 3 degree. So these are the very simple differentiation, and the questions also comes to these. And because all these are unstable, therefore they are very reactive. That is why during the mechanism there is an intermediate formation of these which are quite unstable. That's why they are reactive. So this is all about this video. Have a nice day.